Okay, this video is going to be looking at properties of logarithms. It's going to be some very basic properties, expansions, rewriting, so on and so forth. So by definition, a logarithmic function is an inverse operation of an exponential function. Notice that they have the same base. And you write base to the y, you essentially switch your inputs and your outputs. So the base stays the same. Whatever the outputs are in your log become your inputs in your exponential function. And whatever the inputs of your log are become your outputs of your exponential function. Notice that the domain of a log function and the range of a log function are also reverse of the exponential function. For exponentials, the domain is all real numbers, and the range goes from 0 to infinity. And so logs and exponential functions are just complete opposites of each other. They are inverse functions. If you do not have the base given of your log function, then we say that that is base 10 because that is our number system. And if you see an ln, that is log natural, which is the natural log, that has a base of e. So instead of writing log base e of x, we just write that as the natural log of x. Notice again that e and natural log are inverse functions, and so these things are true. If you have log of e, it basically just cancels out. It's like squaring a square root. And if you have e to the natural log, same thing over here. All right, so let's rewrite these and then also solve them. So my base would be 2. My new inputs would be x, and my outputs would be 64 to do this as the inverse function. So same base, what you're equal to becomes your exponential power, and then your argument inside the log becomes your output value. Well, this is basically saying 2 to what power gets me 64. That's going to be 1, 2, 3, 4, 5, and 6. 2 to the 6th power gets me 64, and so x must be equal to 6. Therefore, we can just say log base 2 of 64 is 6. All right, let's do that again. This one here says 3 as my base. Y becomes my exponential power. And then I'm going to say that it's equal to 1 over 81. I could rewrite 1 over 81 as 3 to some power. So maybe we write this as 81 to the negative 1 first. And then we want to think about, again, 3, 9, 27, 81. Okay, so 3 to the 4th power would give me positive 81. And 3 to the negative 4th power would end up giving me 81 to the negative 1. So y must be equal to negative 4 here. One more way you can think about rewriting this is if you think about 81 can be rewritten as 3 to the power of 4 and then to the power of 1. Remember, powers to powers, you would multiply. That might be easier to then see, well, then y must be equal to negative 4 when you multiply those. All right, again here on C, when I don't have a base, I'm going to assume base 10, so 10 to the power of x. And I have 1,000, so let's do multiples of 10. All right, x must be equal to 3. 10 to the 3rd gives me 1,000. And then in D, I have natural log. So again, this is like writing log base e of e cubed. We just don't write it that way. We use the natural log to undo e as a base. Those are inverse operations. So I'm just left with 3 here. All right, we also have a set of rules for logs in which they can be combined. If you have a multiplication inside the argument, then you can separate those with logs and addition in between them. If you have a division of logs in an argument being the inside of the logarithm, then you could separate those with subtraction. And then power rule, if you have something raised to the power inside the log, you can bring n in front of the log power. So let's use all of those to rewrite this logarithmic piece as the sum or difference of multiple logs. The first thing that I'm going to do is notice that x to the fourth and square root of y are multiplied together. So I can rewrite this as the natural log of x to the fourth plus the natural log of square root of y. Then these terms are being divided by z, so this rule says I can then subtract the natural log of z. I then have two powers. It's probably easy to see the 4, so 4 natural log of x. It might be a little bit harder to see that this square root could be rewritten as 1/2, but it can. So plus 1/2 natural log of y minus the natural log of z. And that would be my rewrite full expansion. Example 3 wants me to go the other way. So now I'm going to notice I have these powers that are written as coefficients, but I'm going to do the opposite of this rule here, and I'm going to say that I can take those n powers up here inside the argument. So I'm going to say that this is the natural log of 8 to the 1/3 plus the natural log of 3 squared minus the natural log of 6. Well, 8 to the 1/3 is the same as the cube root of 8. So this would be the natural log of 2 plus the natural log of 3 squared is 9 minus the natural log of 6. I'm going to then write this as 1 log. If I separate 2 logs with addition, I can pull them inside the argument with multiplication. And if I separate logs with subtraction, then I can pull that inside the argument with a division. I then get, this is the natural log of 18 divided by 6, which would be the natural log of 3.